Hello. In this video, I'm going to discuss a couple different ways of replicating rectangles. Woohoo! Before you start rolling your eyes, just wanted to preview. We kind of discussed, and there's videos, and we're kind of learning short straight lines, different holds for the pencil, ways of making a rectangle and squares with those, making triangles. The fact that triangles are going to help us a lot too down the road. But mostly, I thought I'd start with why am I even talking about this? Why even care about getting good at replicating rectangles? It's fun to say, replicating rectangles. Okay, but anytime we're starting to draw something, especially when we start getting, these are simple, relatively simple, two-dimensional illustrations. When you start getting into trying to capture three-dimensional structures and forms, we're going to want to translate that three-dimensional information into the two dimensions of our paper that we're drawing on. So by creating these rectangles, I talked about the top right and the bottom left, not bottom left, the top and the right and the bottom and the left. Most points of any object we're drawing is something we can identify pretty quickly, especially the more you do it. Here's a good example of really kind of thinking about the fact that this point is a little bit lower than over here. And it takes a while to really get familiar with whatever it is you're drawing. I do feel like, I do it too. I feel like I should just be able to jump right into anything and draw it, bam. It takes a while to wrap your head around what all these shapes are. What are they gonna, how do they interact with each other? How big this part is compared to that part, etc., etc. So it's going to help us translate all that. It's going to help us get accurate proportions. It's a way of going from really general to really specific. It may feel too general at first, and I understand that, and there's other, this is definitely just sort of one approach, but it's, I think, a really advantageous one to get comfortable with, because be using it in regardless of the approach. And let me see, general, and it's gonna help us stop assuming and get rid of our preconceived notions. We may have, you know, an image in our mind's eye. That's a bigger conversation. That an apple is more squat. That's a dumb example. I didn't prepare for that one. But we're gonna, especially when we start moving items, three-dimensional, like I say. Maybe there's a better example. When you think of a pencil, you think of this, and you don't really think of a pencil when it's pointed towards you. So being able to translate that, what's farther away and what's closest to you, in a way that doesn't drive you crazy, it's very helpful to know this sort of rectangular stuff, and then be able to replicate those on your drawing. The two different ways I'm going to kind of talk about two different main ways of talking about rectangles, describing and defining. The first way is proportional, sort of a proportional fashion, and that is basically when we are, talked a little bit about it, but for any rectangle, and I'm assuming these non-rotated rectangles for now, we're going to look at the outer perimeter, and we're going to see which set of parallel lines is the shorter set and which is the longer set. And then we're going to estimate how many of that shorter would fit into the longer one. And that, like I think you may have heard me say, can get your anxious on as far as math and proportion and fractions and stuff. So I really just try to think of it as whichever of these the set of sides is shorter, I'm gonna capture that, and I'm gonna translate that to the other side, and that is really just to create a square. I'm gonna break these things up into squares, and that makes it for me a lot less daunting. And especially when we take the short side and think of how many of the short side are in the long side, you don't end up with crazy fraction numbers. I had this one sketched in. So let's see, I would say that this rectangle is 1 to 1, and man, it's not even quite I'm going to say a fourth. 1 to 1 1/4. This would be 1 to 1 and another one, so 2. 1 to 2. This is pretty square, which means that this side is the same as that, so that's 1 to 1. Let's see, this is probably similar to that, but once again, I'm going to just first of all imagine a square. Let's see, I want to take that measurement and that's about square. So this would be 1, that would be 1, and maybe more like a third. I don't want to get too wrapped up into that, but just know that the important thing is to first think about the short side. How many shorts are in the longs? Interesting. So that's the proportional way of describing it, and that can be a very important way to describe and to be able to replicate. The other one is by looking at the tilt or the angle of a diagonal line going from corner to corner of the rectangle. And there's a couple of different ways for language about even discussing what that angle is. That can get a little mathy. So for right now, I'm just going to mention that one common technique is to sort of imagine that one end is the center of a clock, and that this is the minute hand, and that would be pointing somewhere. If this was a clock, that would be pointing somewhere between 1 and 2. 12 would be up here, 3 would be over here. This one might be more like a little bit more like a 2 o'clock. But I'm just sort of, what I'm trying to do is just think of these angles, and even more so think about the implied triangles that they create. And being able to take that shape in as a whole, start using, our right brain really sees objects in their totality. And if we can start using that to think of, for example, if I thought of this bottom flat triangle as the shoe of an elf or something, I don't know, maybe it's the Grinch, but as opposed to a combination of this line and this angled line and that angled line, that can our eyes can pick those out and match those up pretty good. So we're going to leverage that skill. Anyways, let me do a few examples of how I would go about just tracking down what the bounding box would be for some of these objects. We did it there. Hopefully you can figure that one out. Let's see. That looks like the top there. Farthest right. Here's a good one. Is it the bottom here or the boat, the engine, the motor? And indeed, it looks like it's the motor. And that's the farthest left point. Let me see if I did this flower. That would be the top point. And once again, this is all thinking in terms of a flattened two-dimensional silhouette of something. There's the farthest left. Here's a good one. When things are symmetric, I usually try making an indication sort of in the center. The right would be over there, and since I'm already here, I'll do the left, and the bottom would be like that. Let me stop there for now. And like I've already done here with this rectangle, with these points that I have found, I've sketched in this bounding box. I'm going to do that with the others too. You may notice I'm drawing short, straight lines. It's almost like he did that on purpose. Let me see. Sometimes it's going to be a little bit tricky. Sometimes I don't try doing the whole line at once. Take it in small bits. Good example. By the time I'm getting down to the bottom for there, it's kind of hard to tell if that line, just how straight my line is. We'll have plenty of opportunities to fuss with that. Clean it up and adjust and refine. Oh heck, the guitar. So yeah, you know, these are straight lines that, and bigger rectangles that by no means are a simple thing to do. But I'm going to make sure you guys have this, a copy of this too. I know we looked at a lot of these shapes. So let's just start thinking about how a couple different ways to describe these rectangles. First, proportionally. This one, the flower, is almost square, but it doesn't seem quite square to me. It seems like this distance is going to be, it's close. Seems like it's just about there. I could be more thorough with that if I, or just try to be more careful about measuring that. But I'm trying to just kind of get through these quick. I encourage you to do these quick. Part of the point is to not worry about the drawing the actual object. All we're doing is getting familiar with the bounding box and the proportions of that bounding box. So that was almost square. I'll say 1 to 1 plus. See, this proportional thing gets tricky because it can be sort of non-exact. Well, several things are non-exact, but this seems a bit more like 1 to maybe, it's between 1 1/5 and 1 1/4. This is the short side, that's the 1. That's the 1. And about 1/4 again. I'm not going to worry about fifths. Good God. Fourths is enough. Let's see. This one. Here's a tricky guy. This is all cramped in my finger, but let me see. Would it be about 1 to 1, 2 1/2? I'm doing a couple things, but I'm just chopping it up into squares. It's a little bit pinching my fingers too much to measure it with my pencil. But I'm going to say that the 1, that's 1, and that's 1, and that's about 1/2 again. From there to there. It's about there to there. So I'm going to say that is 1 to 2 1/2. You see, this one I said was 1 to 1 plus. There's a nice specific way of looking at things. This is 1 to 1 1/4. Let's see. That seems like about 1 there. So if I'm breaking that up into squares, it seems like that's 1 to 1, another 1, and maybe 1/3. So that'd be 1 to 1 to 1 1/3. I'm sorry, to 2. To 2 1/3. Bet you had fun with that. It's not 1, it's 2. So hopefully you get the point here. And we just sort of can keep doing that with these. I want to do a quick couple examples of how to translate this information that we've gathered and to replicate that that bounding box. So let me see. I think I shall, let's do a wine glass. So let's see. Say this bounding box is 1, and that's 1, and another 1.5. So I'm going to say this is 1 to 2.5. So if I take that information and I want to make a bounding box that is 1 by 2.5, I'm going to employ the skills that I just learned about making squares. So I've sort of chopped it up into information regarding squares. And now I'm going to take that information to a different place, to my paper, if I can get it. So if I want to make a rectangle that is 1 to 2.5, all I'm going to worry about right now, I'm not going to worry about filling up the page, which is a bit of a whole nother skill. But if you remember, we were talking about making relatively accurate, relatively quick squares. I'm going to test to see if that is basically that. I'm going quickly for demonstration purposes here, but if that's 1, and that's 2 squares, let me check that. Bring that guy up just a touch, which is going to bring that up a touch as well. And then if I want another half, so I'm going to go split this side in half and then just add this portion, which I overstepped. But all of this is meant to get us in the ballpark. It's not meant to be exact and perfect. Once you do this a few times, you'll start getting very quick at it. What if I wanted to do this sailboat and I wanted to do it a little bit bigger? So I'm going to say it's 1 to 1.25. So once again, let's start off with a square for our 1. That seems like it was pretty close. Perfect square. Okay, not really. And then if I bisect these, I could tell the halfway point and then the quarter point. So that's going to be something like that. What you're probably realizing, one of the things about this system is not only does it introduce these numbers, which can creep me out as well as others, but it's not that accurate. It's not sort of it's a great way to get kind of into the ballpark, if that's an appropriate phrase. But the other way to think about these that I mentioned is by imagining the diagonal that would stretch from one corner to the other corner. And that's not the corner of my little square, but of the whole outer bounding box. So for this shape, it would be like that. I don't know if I already, or if I did I do like to do these diagonals in 3 steps. I told you I like 3s. Typically I like to, let's do this guy, I know I'm going to do a diagonal from that corner to that corner. So I'll make a short straight line that I imagine as sort of pointing towards that corner. And while I'm sketching that, I'm literally looking over here. And then I'm doing the same in reverse. I'm sketching this, thinking of pointing that towards that point. And then I'm sketching in the middle, filling it in from the middle. That helps me a lot more than just trying to go once again, I do like these techniques that help me and hopefully help you get to more accurate things that much quicker. So if I want to create this rectangle, what I would, or just replicate this, either bigger or smaller, probably not the same size, but the critical piece of information is the angle of this line right here. So what I'm going to do over here to translate that, to replicate that, is I'm going to start off kind of like I do a square. I have these 3 sides, but I don't know how far down this goes. But the way to determine that is by emulating that diagonal line. And when I've given it a go, I will look at this triangle and see if it really kind of seems like this triangle. I'll put my right brain whole object hat on. And it seems close enough for right now, especially. So that is roughly the bounding box for that. Let's check our math. Let's see if it's actually 1 to 2.5 or close to that. Okay, let's. 1, 2. I think it's okay. Let's see. The more you start getting into these wacky numbers, 2 1/3, the more it can be helpful to say, you know, enough with the numbers. I'm just going to try to see if I can capture that angle, the angle of this line. And I will often use my pencil to help me imagine. And then I can bring it over to what I'm drawing. I think it was about there. hope, I think that's good. You can tell that this rectangle is a little more squashed than this rectangle. And that's how they appear here. I can tell that this triangle compared to this one, it seems pretty good. Certainly good for starting out. All this we're getting pretty quick. Let's see, let's double check this one just for fun. Does that triangle seem like that? Either one of these triangles, you know, I can compare. And to my eye, just real quickly, this triangle looks a little taller and skinnier. And I think it's partly due to this, you know, is it 1 1 1/4? Is it 1 1/5? One of the reasons why getting good at this diagonal method helps is that we can just sort of toss, more or less toss those numbers out. We're still going to need them for certain things. So that is more than enough for one video. Next video, I'm going to sort of talk about how to section the drawings off and to continue to learn about them with diagonals. This is a great example in that, even though this is getting awfully squished and my pencil isn't that sharp, but I can certainly tell that that little rectangle that's on top of the square is very different than what I have drawn here. This is much longer and skinnier, so really it would probably be more like that. And that's making some assumptions. That's assuming that, I don't know if I ever changed that one. Maybe I did or not. So yeah, this is dry to a lot of folks. I'm kind of fascinated by it, truth be told. But and it has helped me quite a bit in my drawing journey. We'll start using this all over the place to break things down into more and more specific parts, and to do it in a way that is, you know, that much more accurate right from the get-go, so we don't have to worry too much about. We can have more fun drawing, heaven forbid. Okay, so I'm going to keep drawing. That's just another quick example of sort of how I would use that, breaking up a shape and then just knowing that the hull of the boat is going to fit in a rectangle, something like that. And yes, it starts getting messy, but that's why we have this lovely kneaded eraser, and things will erase back quite a bit. And if they don't erase back enough, then we bust out our even more serious eraser. So check that out. I'm going to email this thing to you guys, and you guys can go through as many of these, pull up pictures of your own, or do any anything that you want to. But finding that top, right, bottom, and left, generating a rectangle. Will get you off to a great start. Okay.